Hi, I'm Fabio Benedetti and I'm here to present LODeX, a deep group research project for schema extraction and summarization from LOD sources. First of all, let me briefly introduce the linked open data environment. The concept of linking together document and data was first introduced by Tim Berners-Lee in 1989. 10 years later, he introduced the semantic web, and finally, in 2006, he presented the initial design for linked data. The main objective of linked data is to create a universal medium for the exchange of data that can be useful in different domains, as instance, business, science, culture, and so forth. Until now, as main result, we have seen the birth of different standards able to represent data as linked data. These standards are RDF and RDFA. Another important standard is the SPARQL query language that allows the user to query RDF sources. In the last few years, following this principle, started the publication of open data as linked open data. These datasets form the linked open data cloud. In the picture, you can see a famous representation of this cloud in which each circle represents a distinct dataset. Now, with this slide, I want just to focus on the continuous growth trend of linked open data. In fact, in the 2009, the number of datasets were almost 300, while now their number has surpassed the 1,000. We find out that the semantic web technologies are really complex for unskilled user. This drawback decreases the usability of linked open data. For this reason, we started the development of LODeX, a tool that tries to automatically extract and summarize a schema for a generic linked open data dataset. Given a linked open data dataset, LODeX produces as output a schema summary. The schema summary represents the structure of the dataset. The schema summary can also be used to support the user in the query generation task. In fact, using LODeX, a user is able to extract information from a generic linked open data dataset without having any knowledge of RDF or SPARQL. Now I'm going to propose you a brief demo of LODeX. Here is the main page of LODeX, where you can visualize the list of the dataset indexed by LODeX. Here you can order this list using different characteristics of a dataset, as instance the dataset name, number of triples, class numbers, and so forth. By clicking the green button on the right of a dataset, you can visualize its schema summary. The schema summary is a graph in which each node represents a class. Going with the mouse over a node, you can have an overview of the characteristics of this class. On the top left, you can find the class name, followed by the list of properties, and finally the list of attributes of this class. By clicking on the green button on the left of the class name, you can start a visual query. Now you can enrich the query adding some attributes. By clicking on M or O, you can choose if an attribute is mandatory or optional. By clicking the Generate button, you can now generate the SPARQL query. This is the refinement panel, where the results of the query are automatically provided to the user. Here you can also visualize the SPARQL query. On the top of this page, there is a panel that you can use to modify the query. After any modification, the SPARQL query is automatically compiled and resubmitted to the endpoint, and the result shown to the user. Now let's do a more complex query. We can return in the schema summary panel and delete the previous query. This time we started the query with the class organization. We had also some attributes, name, abbreviation, and city. We also had the state attribute as mandatory, keeping in mind that the cardinality of these attributes is just 0.3. Now we notice that we get just 800 result, so we can use the refinement panel to change to optional the attribute state. The number of results increased to almost 300, and we notice that not all the records in the table contain the attribute state. We choose to limit the default page size to 50. In that way, the user can have a very fast response from the endpoint while he is modifying the query. In the refinement panel, the user can change the page size and can also browse between the different pages. Now let's pretend that we want to find the organization of London. We can use the refinement panel to add a filter condition on the attribute city. The number of results has dropped to 97, and in the results we have just the organization of London. Here is the SPARQL query with the filter condition on the attribute city. Now we can expand the visual query adding another class. For instance, the class feature that is linked to organization by the property active-in. We had also the two attributes of this class. We can now generate the corresponding SPARQL query, and we notice that it's becoming quite complex. Looking into the result, we can imagine that the class features linked by the property active-in contain information about the country where the organization are active. Using the refinement panel, we can also add ordering condition. In this example, we add an ordering condition on the attribute name1 of the class feature. In the SPARQL query panel, the user, if no SPARQL, have the possibility to manually modify the SPARQL query. For example, in this query, with a few chains of the SPARQL query, we can obtain in how many countries each organization of London is active.